This is the homework for 130, 136, and 140 for foot size. In Part A, it was not practical for Kieran to measure her classmates' feet, so Kieran collected the following shoe size data from some of her classmates. Make a graph with appropriately scaled axes. So here's my graph, and I used the data in the table to determine the scale of my axes. And for the height ranges from around 153 to 170. So I don't have any height that's less than 153. So here you see I have these two squiggly lines. It's called an axis break. And the reason why I use that is because since I don't have any data less than 150, there's no sense for me to put that on the y-axis. So I'm going to start my data at 150, and you can see here every two boxes is 5 centimeters in height. 2 more, 5 more, so 160, 165, 170. And from here to here is 150 centimeters. So I had to put that axis break there to let people know that's reading this graph that this two boxes does not represent 150 centimeters. So there's the axis break. On the x-axis, I have shoe sizes ranging from 6 to 10. Well, I could have used an axis break here as well and maybe started around 5, but I chose to start at 1, so every box represents one shoe size. So 1, 2, 3, 4, and so forth. And then I went ahead and plotted my data from the table. So shoe size is 6 on the x-axis, and 153 on the y. And I did that for all my data points. So part B, is there a relationship between the shoe size and the height? And if you look right here, all the data is clustered right along this pencil. And you can see that there's this positive trend. It's increasing. So as the shoe size increases, so does the height. So there is a relationship between shoe size and height. Students with larger shoe sizes, so as the shoe size increase, tend to be taller. In 136, we need to compute the value of the following expressions. 3/7 divided by 2/3. Well, when you're dividing fractions, you take the reciprocal of the second term, 2/3, and the reciprocal is 3/2. Now I look to see if I can cross simplify, and I can't, so I multiply the numerators. 3 multiplied by 3 is 9, and the denominator, 7 multiplied by 2 is 14, so the answer is 9/14. In part B, we have 1 2/10 divided by 4/100. So I'm going to use long divisions. 1 2/10 divided by 4/100. We're going to eliminate the decimal in the divisor by multiplying it by 100. So that moves it 2 place values. And we're also going to do it to 1 2/10, and we multiply it by 100 as well. That moves it 2 place values. And bring up the decimal. So now we have 120 divided by 4. 120 divided by 4 equals 30. In 136C, we have 11/4 of 3/7. Of, in this case, is meaning multiplication. So we have 11/4 multiplied by 3/7. Look to see if you can cross simplify. We can't. So now we're going to multiply the numerator. 11 multiplied by 3 is 33. 4 multiplied by 7 equals 28. So we have 33/28, which is an improper fraction. So you could reduce it to 1 25/28. In part D, we have 4 1600 multiplied by 2/10. When you have parentheses, this is indicating multiplication. So we have 4 and 1600ths multiplied by 2/10. 2 times 6 is 12, regroup. 2 multiplied by 1 is 2, plus 1 is 3. 2 multiplied by 4 is 8. And now we count the place values, 1, 2, 3. And so we're going to move the decimal 1, 2, 3 places. And we have 832 thousandths. So 832 thousandths. For problem 140, the pattern below is composed of nested squares. So since we know that they're squares, we know that the length of each side is congruent. So if this is 2, 2, 2, and 2, and the inside square, 1, 1, 1, and 1. So now we need to draw the next figure in the pattern. So if you look, we have 2, 1, 3, 2, 4, 3. So the outside, I see the pattern of 2, 3, 4, 5. And then the inside square, 1, 2, 3, 4. For part B, we need to find the area of the shaded region for the figure. So here's the shaded region. And you know that we have the outside length of 5 and the inside length of each side is 4. So we need to find the area of the inside and the area of the outside. Area, remember, is length multiplied by width. So we have area equals 4 multiplied by 4 because the length and the width are both 4 because it's a square. So we have the area of the inside square equals 16 units squared. Now we need to find the area of the outside. So again, area equals length multiplied by width. We have 5 multiplied by 5. So area equals 25 units squared. So now, to find the area of the shaded region, we need to subtract this inner square to leave just this red part. So we have the outside minus the inside will equal the shaded region. So outside is 25 units squared minus inside 16 units squared, which equals 9. So the shaded region is 9 units squared.